They're not thinking about it in their day-to-day activities. They don't come into work thinking, how is my building getting powered today? It's just, it does. Until something goes wrong.
They said all they saw was a flash and heard a boom, and they went into the room and it was full of smoke.
In the summer, which is when a lot of schools do construction projects, toward the end of the project, they were starting to bring power back.
And we all went inside the room, we took a look at it, noticed that they had several burnt portions of sections of switchgear.
They had an arc, and it actually spread throughout one of the cabinets vertically.
There were blast marks against the wall.
It actually blew open some of the doors.
The gear itself was filthy before it actually got there. That's probably why the whole thing erupted so bad.
The old switchgear was 40 plus years old and never really been tested.
Dirt and dust are contaminants, and they actually take away from the integrity of the structure because they're conductive.
The arc melts and actually vaporizes the metal in the switchboard. It's so hot.
From what we understood is that they never operated anything for 10 years. If it doesn't move, it gets stuck, and the incident energy is going to make it move. Well, something's going to give.
Copper expands, and the air expands. So with everything expanding, that's what's causing this explosion, so to speak.
So if you have an incident that causes a high inrush of current or energy, all the rest of the stuff is going to react to it, and it's going to take everything with it, which is probably what happened in that gear.
So we came in and played two roles. One, we came in to see if anything was salvageable. And then later on, when everything had been replaced, we came in to test the new switchgear.
Part of the whole thing was preventing the delay of the opening of the school, and that's why we had to get out there the day that we were called to go look at it, dispatch with a full crew the next day to test it so that we can give our findings to the contractor, to the school board, and the insurance company so they could determine what needed to be purchased and get that all expedited in, and they met their school date by about a week.
Our world we live in is becoming more and more electrically dependent, and due to that, you got to have reliable systems that deliver that power to the companies that use them.
In the 1940s and the 1950s, did a lot of construction and infrastructure.
The stuff that's built 50, 75 years ago was super robust, over-designed, using 3 times the materials, 3 times the size.
But we're starting to see now that a lot of that infrastructure is starting to degrade.
This power equipment, the switchboards, the breakers, have been around for a long time. And you get a building that's 20, 30, 40 years old, if you've never taken a look at it, eventually something's gonna happen.
And what I can share with you is when we go in and test it, we actually end up covering more issues.
I think a lot of people don't want to test their distribution system because it means they got to turn it off. I mean, I've heard it said before, if you don't turn it off, eventually it'll turn itself off.
Because some of these systems haven't been mechanically operated or electrically operated in years.
It's one thing if the power goes out and okay, the lights go out and the heat goes out. I can work through that.
In a lot of cases, you're selling a product to somebody based on the performance of what your company can do.
It's another thing when your whole business is being stored on a computer server. Now the power goes out and you've got an hour of battery backups for that server, and then you might lose everything.
And if you're not aware of the condition of the power being delivered to your equipment to run your site, you could be blindsided.
And what do you do then? And so the things that we're powering are becoming more and more important, and so the reliability of that power becomes more and more important.
You could get shut down for weeks, and in those cases, your customer might not be as satisfied with how reliable you are.
Really, if one component fails, a circuit breaker, a $2,000 component fails, but you have 2,000 employees out of work, the supplier of the circuit breaker is not going to warranty the loss of time on the whole manufacturing facility.
You figure like a 1,200 amp circuit breaker, multi-case circuit breaker, is worth about $15,000. If that fails, they don't make those off the shelf. You can't run down to Walmart and go get another one. You have to wait for another one to be manufactured, shipped out to you, and then it has to go through its normal process. It has to get to you, you have to open it up, put it back in there, and of course it has to be tested. That process can take a week.
Power goes down, you lose money, period. And you hope nobody gets hurt through some kind of an electrical fault. So regular maintenance is the key.
Well, there are certain things you can do without shutting your equipment down.
The best thing obviously is to go ahead and do an inspection on the gear without getting inside and moving things around. The next best thing is do an infrared scan, which is looking for hot spots.
You just have to make sure that you have the proper PPE to open the gear, and you should be able to identify hotspots with bad connections.
Which is not the end-all be-all, but at least it's better than nothing, and you can identify some portions that are deteriorating just by how much heat has been given off.
Finding a time to shut down the equipment and test it is really what needs to be done.
Loss of revenue is the biggest thing, especially with data centers. But even they have scheduled outages to make sure the equipment's going to keep stay up and running.
Second thing is de-energize it and clean everything. Dust, corrosion, having moisture inside your switchgear is the worst thing for it. The next thing is you want to test the insulation, and that's the ability for the electricity to stay inside the gear. Then you want to measure how well the circuit breaker reacts as far as timing goes, long time, short time, instantaneous. And you want to measure the integrity of your transformer, and that'll give you an idea of how long your system's going to last.
And there are ways that you can minimize the shutdown time. This portion of the building we can't shut down. So bring in a backup generator, keep power to that portion of the building, and that allows you to test the rest of it.
We have the equipment to test breakers at a very rapid speed, given the amount of equipment we have and the technicians we have to do that testing.
One of the questions that I get asked is, okay, is there a law that says I have to do that? And the answer to that is like, there is absolutely no law that says that you have to test any of your gear. However, you are responsible for providing a safe working environment for your employees and everybody that's in your working space.
Because at some point in time, the stuff's going to have a problem, and somebody's going to have to come in and fix it like us. So it's better if you have a regular maintenance schedule to come out there and take a look at the gear.
And that's what we do. We make sure that those circuit breakers, those transformers, the cables, and all of the systems that support these facilities and power critical loads are maintained and also react when you want them to react.